So basically, this is a day three of AI webinar. So just to give a glitch, just to give a inst like how what is the purpose, and also in the last two webinars we kind of covered what is AI, what is machine learning, what is data science, like the different roles that you see in the job market, and how do we describe the role, like based on the role what are the skill sets that you need. And we realize it that bottom down the line it's the same contents but just with the different names with respect to the different companies. So that was one clarity that I have given to all the students. And in the second session I just got a little bit deeper into the machine learning parts and the deep learning parts, like what are those, how will they work, and what are the types of machine learnings, what does a deep learning can do, and why do we use deep learning, why do we use machine learning. So these are some of the basic things that I have covered. So if anyone missed it out, just go back and see those two recordings that are available on YouTube. Uh, and precisely, no need to worry. It's a fresh session on each day. So day one, nothing got to do with day two, and now it's day three. It's purely NLP. It's a natural language processing. So it's a complete different kind of, or like I can say, it's all to together a new chapter for this data science. So basically this natural language processing is something that I can give you a best example is I think everybody uses iPhone now, Siri. It's a natural language. See, because whatever we speak, it understands. The machine is understanding what a human is telling. How is that possible? So let's say tomorrow I keep a video, so it kind of takes the summary of that video because it listens to the text that I'm saying and then it will give. Or let's say if I'm giving a speech and then the machine will write everything, like if you see the Google Word doc or your voice messages, so how it's going to type it. So it's purely the basic underneath the knowledge is natural language processing. So let me quickly go take you guys into that. Let me just sharing my screen. Let me know once you're able to see my screen.
Yes, we can see your screen.
Cool. So 1 second. Yeah. Yeah. So this is something called NLP basically. NLP is nothing but this is natural language and this is processing. So see, just understand the just natural and then the language, whatever we speak, it's a language, and how do we process it? So that's the uh, crunch of this NLP part. So first let me tell you what and all languages are there, like what and all the things that we can do. Like let's say if you see take any country like Hindi, every country has some national language. So the most spoken languages in the world are these, like Hindi, Bengali, Punjabi, Chinese, Russia, Japanese, English, Arabic, Spanish, and Portuguese. So there are, for each language there is a different set of dictionary, there is a different set of alphabets, different set of words, different set of meanings in different contexts. Each word has different meanings. So if you take any, like let's say in study of neuropsychology or linguistics on the philosophy of a language, so natural language or an ordinary language is that like it has evolved naturally in humans through like use of repetition without conscious planning or premeditation. Like let's say if I'm a new guy, if I wanted to speak Hindi, so first what I'll do, I'll try to sit with the people who speak Hindi, try to understand what they're saying, and then get used to the basic words that they use daily, and then watch movies, understand the language and the context behind each word in the situation. Because see, using the right word in the right situation is something that is most important for a figure of speech or something. So everything, how does a machine can understand all these things? It's beyond imagination, right? So, like, let's say natural languages, like they can take different forms, like such as speech or singing, or you're asking the Google Docs to write speech to text, everything. So, uh, and there is one more thing. See, there is a sign language. How does this will get understood? How, like, sign language? See, because these are the languages, basically, that use, let's say, visual man, like, let's say, in a visual way, like, uh, we say fingers, okay, this like this, we say the words and then it combines, form a word, and then that word will be communicated by the person who is able to understand it. So, sign languages are expressed through manual articulations in combination with non-manual elements. So this is one beautiful thing. So, be it a language that you speak or be it a sign language, so these are all the language types that we have. But if you see, one point is common, one thing is common. Every language, be it a sign language, be it a normal language, be it any other facial expression knowledge, anything, the core idea is to learn. That's the point where, like, that's the major point, like, learning, start learning and then be provided. So the same way, machine will try to start learning the things and then eventually it'll understand the things. So if you talk about the whole world, like, let's say these are some latest stats that I've picked. So English is the most spoken language, and next is Mandarin, next is Hindi, next is Spanish, French, Arabic, Bengali, and then Russia, Portuguese, Indonesia. So English is the largest language in the world. Like, if you count both native and non-native speakers, like, English has the most. So now, what if we talk to, like, if we learn only this language to a machine, so that machine can help you in all the states or countries that is using only English language, which is major, correct? So that is one thing. So if you talk about the programming language, see, the difference between natural language and programming language is something. Natural language is something we speak to make others understand, whereas programming language is something based on a set of instructions we make the machine understand what it should do, and then we will ask the machine to do a set of instructions or something. So there are a lot of programming languages now, like, let's say, C language, COBOL, SQL, C++, Python, Java. There are a lot of languages. So you have programming languages, you have sign languages, you have natural languages. So there is a lot of, majorly these are the different types of languages. So how do the machine takes these language types and process it? And let's say, before to that, let's say, uh, how will machine understand my language? Okay, in programming language, okay, I'll write some set of instructions based on the coding syntax and all. The machine understands and do it. But what is its limitation? Its limitation is only to the system. But whereas in the human language, you can speak any language, but the machine understands it. How? So to answer all these hows, there is a concept called natural language processing. It's a purely an AI intelligence. Like, let's say, it's a part of research area in artificial intelligence. Like, how do we process the natural language like English, Hindi, Portuguese, Mandarin, and all. So if we do this process of translating natural language into data that computer can use to learn about the world. So what will happen means, so let's say you have the, so when you give this word to a machine or robot, it will not understand. So this will get converted to numbers, maybe 0 1 0 1 0 1, something like that, and it will get stored in the machine. So whenever you give an another word, it will try to first map to its vector and then do the process and then reply it back. So whatever the word, be it any word, it has to be converted into vector and then stored, or it will learn. So if you see, the word natural language is used in the same sense that is used in natural world. but both are different. See, natural world is different, natural language is different. So, like let's say the movie is good. This is normal sentence. Yeah, and if we say it in a sarcastic way, like, yeah, movie is so good, yeah, you have to go and watch it right now. See, the sentences are same, but the meanings are different, and the people behind it are different, and the context is different. So how will it able to understand whether it is a sarcastic word or it is a real sentence? How it can understand? So that is just keep that apart. How keep that apart? Now, what are the major problems in NLP? Like um, let's say non-standard language or segmentation issues. Like let's say if you see this example, great job at the rate Justin Bieber. We are so proud of. See, there are some words which are not even in the dictionary. How will the model can understand the words that you keep? And also there are some machines like let's say with the capability of processing something natural which is not natural. And don't think like natural languages can directly translate everything into mathematical operations. No. So what will happen first, it will take a word and then it'll check what and all are there. It let's say WORD. There are four things. So each letter will be converted into vectors. And then this complete vector is stored and represents the word. So this so the major problems is like identification of this every language like natural language and some like when we say giving a garbage which are not meaningful at all, and then you ask a machine to give you an example or machine it cannot do it. So there are a lot of applications of this NLP. Like let me show you some. Like let's say if you see search Google search, like you can see whatever you search in Google, right? Whatever you search in Google, right? So I'll just tell you how the Google works. So here is your search bar. So let's say when you want to search data science, when you say data science, so what will happen? Google has large amount of data stored in its database with all the vector forms. So the moment you enter data science, it get converted into vectors and it will do a similarity search in its data set. Like let's say you have one vector here, you have another vector here. If the distance between these two vectors is small, that means these two vector points are quite similar. So the same formula it uses. So it kind of checks for which vector the distance is less and it collects all the information and it will show as a search results for you. So that is where NLP majorly comes into the picture. Like let's say, be it a search or be it like writing or in email. Like let's say spam filtering. Like how are emails going into your spam box? And let's say if you see sometimes when you write thanks and then in the suggestions it will give you thanks in advance or like let's say you're welcome, there are some suggestions it will give. So that is NLP. And you can do text mining, lot of text extraction you can do, and you can do sentiment analysis. Sentiment analysis is a very important topic. So sentiment analysis is something like let's say you're giving a review whether we should say whether it is a positive or negative. So let's say if you want to talk about that is what I said, right? Movie is good, it's a positive review. Movie is not so good, negative. So based on the reviews that you give, it'll kind of do a sentiment analysis to understand whether it is a positive review or a negative review. Okay. So this is one of the these are some of the applications I should say. Some of the applications that we use in the real day-to-day world, like be it anything like chat GPT or like let's say Facebook, everywhere NLP is there. So this is what the internal architecture does. See, NLP is something which is natural language understanding. Oops, sorry, natural language understanding plus natural language generation. That is equal to natural language processing. So first it will understand what a person has given, and then it will try to generate based on the words or a keyword. So this is what first it understands it and then it generates it. So that is the reason it comes with NLU plus NLJ. Okay, so there is one more thing. So let's say if we talk about like let's say natural language understanding. So first it will try to see the meaning, like what is it, what is that he's asking, or like how we generated and all. So with the meaning, using the natural language generation, it kind of creates this text. So if you see this diagram, I just kept it here. See, NLU is something, it's just understanding. See, relation extraction or semantic passing, question answering, sentiment analysis, dialogue agent, summarization. So it understands, it will do summarization. It understands, it will say whether it is a positive or negative. So like this. So on top of it, we have a lot of things like named entity recognition. So NER, named entity recognition means identify what are all the major important features of this. Like let's say if we are talking about the movie, what type of movie, and what is the reviewer rating that he has given. So this kind of named entity recognition, like any names are there, anything, and parts of speech tagging. So you know, right, this right, parts of speech. So it's a basic English, guys. So and then next it categorizes the text, and then see the syntaxes. So these are all the things that are there in NLP with process of NLU. So if we want to say like text to speech, yeah. So text to speech is something like let's say first you speak something, or like let's say Siri has, you asked a question, Siri understood that, and then it kind of gave you it kind of gave you some response, but Siri has to speak. So whatever the text that is being generated, it is kind of saying those text into the words. That is called automatic speech recognition, ASR. So this automatic speech recognition, this NLU, NLP, which is a combination of NLG. Okay, these are the major important aspects with respect to natural language processing. So now I have introduced you a word, speech recognition. Let's say, guys, you guys are understanding so far? Am I going too fast, or it's okay? You're able to get it?
Sorry, can you repeat the last part? You said text to speech is a combination of NLU plus NLP.
Yeah. See, text to speech is something. First, like let's say you have given a prompt. You asked Siri a question, so that first Siri will understand what is the thing that you have asked. So which is NLU, natural language understanding. So based on the understanding, it will generate something, natural language generation. So with respect to this, there is something called automatic speech recognition, where it reads this generation part here. Okay. Hello. Hello.
Yes,
uh
sorry, I was talking on mute. Sorry.
yeah, yeah, cool. Thank you. So let's talk about speech recognition. So as I said, like speech recognition is something. It is also known as an automatic ASR, which is nothing but automatic speech recognition, or a speech to text, or like let's say computer speech recognition. So the major thing is it enables the program to process human speech into a written format. So uh, you have a lot of things like, let's say, but the more advanced is AI and machine learning. So the moment you use AI and machine learning, it kind of writes everything what you are speaking on mic, like grammar, syntax, structure, and your voice signals also it will take. Like, let's say, if I'm using a loud pitch, so it will kind of bold them. So it is kind of understanding the way that you speak and understanding the uh, basic, like, let's say, knowledge, or I can tell you in such a way that uh, what do you call that? So it's the basic generation that we use for speech recognition. So again, this natural language, so this natural language understanding is again, see, mainly into two things. I just kept the definition and this thing. So this is again the backend code behind this is the backend code behind this is like it uses a computer software to understand the text and like any type of unstructured data, because see, the text it is all unstructured, right? Like you have a document with lot of files, and I'll say in the document name I'll keep it as reviews. So with respect to reviews, it has lot of documents, so this purely unstructured data, not structured. So what will happen with this NLU is take this unstructured data, understand the pattern, and then divide them accordingly. Divide them accordingly. So this is what it happens with respect to NLU. So there is some more thing. Um, so it's mainly the main responsible for this is like text categorization or content analysis or sentiment analysis. Like, let's say, Alexa, what is the weather like outside? Or Siri, how is the traffic this morning? Hey Siri, what is the latest news? Hey Siri, play a song. So these are some of the basic things. See, I just my phone was next to it, and then when I say hey Siri, it got activated. See, it is playing a song. Just let me stop it. Yeah. So that's how the fast, that's how the accurate artificial intelligence is with respect to NLP. So these are some of the resources, like Microsoft has Lewis and IBM has Watson, and Azure services also there, like to do this processing of understanding of things and everything. So now we have, and like, see, processing is, I said, combination of natural language understanding plus natural language generation. Correct. So uh, like, let's say, now let's see what is generation. So generation is like produce some meaningful phrases and sentences in the form of natural language. Like, let's say, uh, um, natural language generation is something it cannot read, it can only write, because the generation, the word generation means it generates. So after understanding, based on the understanding, it generates the text. So when it's generate the text, it has a lot of things. Like, say, NLP, NLU. The understanding takes the part of like understanding of data based on grammar or the context in which it was said, and decide on intent and entities. But whereas this NLG, it generates the text based on the structured data. Like, once you understand the data, everything based on the question, this NLG will generate it. So the combination of this NLP and NLG is again NLP. So and see, with respect to natural language understanding, we have resources, and with the combination of AI and machine learning, that's the state of the art. The same goes with generation. So generation is also, it's the same. It's like it automatically transform data into like plain English content. Like, let's say, like it looks at a language and figures out what ideas are being communicated, and then NLP system, an NLG system, it will start with set of ideas which are there in the data, and then it will try to keep them into language, and then it communicates with you. like let's say Alexa, Cortana, like where they'll hear us. Like let's say even this Amazon Alexa, right? See, if you keep this at home, it always hears your conversation. So let's say if you're talking to your wife or husband regarding buying a product, the next moment you open Amazon or Instagram, it the moment you have spoke about that, it will recommend. Okay, you can see this, you can see that. So that is how the AI is making you whatever you speak, it is taking into consideration and then making the market much more available to you, which is quite a good way and quite a dangerous way to. So these are some of the things. So let's say if I talk about NLG use cases like reporting or like let's say individual client or IoT devices status and personal communications, and with respect to like see, to do all this first we have to do understanding the human language for production, and these are some of the things that generally goes with like the NLP is something, the NLU and NLG both goes hand in hand to make it a natural language processing. So uh, now, okay, oh, I understood what is this, what is that. But now, how will my machine understand when I try to build an NLP bot or well, let's say NLP application I have which have a lot of text. Let's say take sentiment analysis. You have lot of reviews. You have lot of reviews. So on these reviews, you have to say whether each review is positive or negative. So what you will do, what generally what machine learning does, like if you guys have seen my previous classes, so machine learning is something. First, it will train on the existing data. It will train on the existing data, and then it predicts. So the same goes with here. First, we need if you want to do sentiment analysis. First, we need a document with set of reviews, and each review says positive or negative. So if you have with this type of data, so we can train a model on this and we can send a one of the file to this model and then it will say whether it is a positive or negative. That is how it works. So even like let's say machine translation, it's also the same. So like let's say in machine translation, like sometimes like let's say uh, uh, your machine kind of translates it. Like let's say you say hey namaskar. Let's say hey namaskar. Namaskar is a Hindi word. So if you want to translate it to English, hey, hello, greetings. So to convert this thing to this, we have this called machine translation, where the machine translates from one language to another language. So it'll kind of it has an automatic thing like which converts the source text of one language to text in another language. So yeah. See now the major important things that I want you guys to take away is see first given a word or given a phrase, first we have to do some understanding like how we'll do understanding, we'll do pre-processing. We'll do pre-processing like let's say I'll show them in the demo right away. So we need to kind of do pre-processing and once pre-processing is done, if we have trained data available, just predict on that. If not, train a data and then predict. Even with respect to this machine translation also is the same. So the major key takeaways that I want you guys is uh, mainly sorry. Yeah. So mainly I want you guys to understand is like this. See, NLP is a combination of so it's the combination of NLU plus NLG. And then if you want to have speech recognition, then we have ASR. If you want to have machine translation, then it is MT. So that's it. These are the four major concepts in NLP. That's it. So you guys have any doubt so far? You guys have any doubt till now? Any questions, guys? You can ask me. Now I'm going to show you guys a demo, the basic like the
Excuse me,
NLP.
sorry, what's the ASR again? What was that?
Automatic
Mm,
speech recognition. I told you, right? Like the
mm.
ASR is nothing but the automatic speech recognition. Like let's say,
Okay, I remember. I remember. I
yeah,
just didn't get the. Yeah.
cool. So any other questions, guys, from the other people? I'll just have a bit of water. Just give me 1 second. I'm back. So now, so this is the major crunch. Like, see, the beauty is how AI can understand your data. How does it will make your data into vectors, and how can it kill store, and how can it understand? I told you, right? The major thing is to do a similarity search and get you the results. It's the pure cosine, the similarity. If you say cosine similarity, it will be difficult for you to understand, but just bit distance between vectors, if it is small, that's it, boom. So now let me just show you guys an example. Yeah, let me know if you guys able to see my screen. You guys able to see my code? Hello, guys, can
Yes.
you hear me?
Yes.
Yeah, cool.
Yes.
So yeah, so this is a Jupyter notebook. This is like it's a data scientist user friendly tool. So NLTK is nothing but natural language toolkit. So you have to install this from pip library. So now I have installed it, and now let's say if I just run it, it'll run. And now if you see, I have a paragraph here. Narendra Modi Das, Gujarat is a current, and there is lot of text. If you see, if I just in the downline I have printed the paragraph. If you see this is the complete paragraph I have. So now I want to understand like what can I do with this data? Like let's say this is the paragraph I have. That's it. I don't have anything else. So um, what are the steps that it uses to understand the paragraph and make it simple? The beauty is, see, there are mainly four steps. Like first, divide this paragraph into sentences. Remove all the stop words. Stop words means is, a, and, the, with. So all these verb words we call them as stop words. So NLTK toolkit has an inbuilt dictionary called stop words, where we'll remove everything. And once we remove all the stop words, the whole paragraph will be with only the keywords. You guys are getting it. See, first it is removing the unwanted lines or unwanted words in the paragraph, and it is keeping only the major ones. So let's see how it goes. See, now first I'm doing a sentences. See guys, if I tell what is POTSTEM tokenize, so it's a lot of Python and lot of NLP knowledge that we'll be teaching in the regular classes. But yeah, see now with respect to NLTK.stem, import POTSTEM, and then see first I have converted that complete paragraph into sentences. If you see, this is a sentence, this is a sentence, and this is a sentence, and this is a sentence, and this itself is a sentence. This, so like this we have converted. So now after this, see, if you see something, I have given a word history, but it gave history. So in a sentence, like let's say go, goes, history, historic, historical. So for all these three words, the root word is history. So stemmer is something, it gets the root word of every word. So if you have three words like history, historical, histories, so it will take the root word only history and keep only the one root word and remove all the three words. See, you're reducing the paragraph and you're reducing the paragraph, and then you're removing the unwanted things, but at the same time you're remembering the most important words. Okay. See, now let's say if I say go, goes, it has something called go. So now with respect to all the sentences, first make everything to lower and then remove stop words. See, remove stop words and then keep the words. See, now finally if you see the final corpus, see, Narendra's Modi Godi ji, Gujarati N mode listen September. See, these are all the root words. Indian politician serving, current prime minister India since. So these are all the key words, I mean the root words, and you can see there is no a, no is, no than, the, it, anything, because we have removed all the stop words. So now we have a paragraph. From that paragraph we have ended up with the meaningful sentences. Now for each sentence, take what and all the important words. See, these are all the important words. These are all the important words. These are all the important words. So now there is something called count vectorizer, where it will take each word and convert that into vectors. See, when I say x to an array, see, it kind of stored everything into zero. See, this is one, this is one, this is one, this is one, this is one. So if you see the vocabulary like Narendra 56, that means when you do this 2 power 0, 2 power 1, the value will be 56. So like for each and everything, you'll get it. See, see the beauty from this paragraph. From this paragraph, you just ended up with this. This. See, this is your final array value. Did you guys understood now the beauty? So, starting from a paragraph which has no meanings, like it's like that, like what, however it wanted, it just acted it like that. But at the end, you have a meaningful vector. So now you can play with this vector however you want. See, now this is a vector 0 0 zeros, and now the label is let's say positive review. Let's say positive has one vector, negative has one vector. So now my vector is input features and the vector is another output feature. So now you can train the model, and then whatever the input that you give, first convert that to vector and then send it to your model, get the output. You guys are understanding it? Can we use stop words? No, we cannot, because it doesn't make any sense. No, see, if we use stop words, like let's say is, a, and, the, what is the need of you storing them? So that is the reason we remove those stop words, to make the machine, the paragraph or a sentence more meaningful with only the meaningful words. Okay, meanwhile, I will show you one more thing. Yeah, so if you see this NLP, right? NLP is nothing but, as I said, NLU plus NLG, correct? So, can I know the remove? Can I know the remove the emoji from the sentences? Yeah, see, unwanted, like when you load that file into Python, those emojis will not be same. They are made up of special characters like campus and question mark, and then like colon, and then the side arrow. So there are a lot of things. So those all along with the stop words will be removed, because those doesn't make any sense in understanding the crunch or a context of it. So now if you see, now we understood how we do NLG, how we do NLG. So but see, sentiment analysis is something you go through a word and then you predict it, whether it is a positive or negative. Okay, but but how do we let's say if you see, when you say like hope, comma, I will, and then it will give you a suggestion like recover soon. So that means it is predicting your next word based on the previous words. How? And second thing, like let's say sometimes you wanted to know the middle word, and you have here some sentence, here some sentence. So to predict something in the middle, you have to know the previous words and you have to know the afterwards. So both the words you have to know to say, okay, this could be my potential word in between these two. So how again? So this is where the RNN comes into picture, which is a deep learning of NLP. So RNN is nothing but it's a recurrent, it's a recurrent neural network. So with respect to this recurrent neural network, so the major goal is, see, this is the idea. That's it. So you give a word, it'll predict a word, and then it'll calculate the error, refeed it to it, and then do the same process like this. So with respect to this, there are mainly two themes, which is called LSTM and bidirectional LSTM. LSTM is nothing but long, short term memory. So in the words that you are giving, it will see short term memory. It will remember these words to predict the next word, and then it will remove those because it's a short term. Bidirectional LSTM is something you want to predict this word. So bidirectional LSTM is something it remembers the words in this way, and the same as it remembers the words in this way. So it's a two-way. That is why it's bidirectional. Okay, so this is how this is the main thing. So now from this the advanced part came into picture, like let's say you have next is encoders and decoders. Encoders and decoders nothing but you give any text, first it encodes and then it decodes and then it gives you output. And then next you have something is something called as transformers. Transformers is something you give a text and then you go through the transformer mechanism and then you get a text. You get a text. So the now the latest example is chat gpt, the open AI LLM. LLM is nothing but large language model. So you give a text, it produces a text. So starting from LSTM, it has evolved these many things to reach to the latest part, which is LLM, the large language models. So starting from understanding of text or like converting the text into vectors, you ended up with OpenAI, which is an LLM where it takes a bunch of text and gives you a bunch of text. See the evaluation, guys, of AI. Back in 27 to 2024, see the evaluation, how this evaluated. That's the major beauty with respect to the data science and AI. So with respect to this chat GPT and OpenAI, like we'll kind of cover in the next session. The next coming week is on the advanced topic of LLM, like what is LLM and how we can use it. I can clearly show you the way you use chat gpt, and if you do the same prompt in the python coding, it gives you the output. How? So these are some things, some langchain architectures that I'm going to teach. But this is how the langchain evolved from the natural language processing. It kind of processed different types of inputs, different types of languages, different types of context, different types of domains. So all together they created something called llm, large language model, which has everything. And that is where it gives you bunch of text from the text that you have asked. So this is all about the NLP and the evaluation of the LLM. So yeah, with this I'll just stop my class here, because this is what I wanted to cover today. I want you guys to make understand how an NLP is and how does it look. I just wanted to show you guys a small demo. So